we're given the fact that angle 1 is complementary to angle 2. Colin, what's that mean, complementary? Add up to 90 degrees. Does everybody know that? Add up to 90 degrees. So we know 1 and 2, these two add up to 90. They're complementary. They tell us angle 2 and angle 3 are congruent. What you should do on your picture, anytime you're doing one of these two-column proofs, draw the picture so that you can do stuff like this. My pen works. What's that tell me about those two angles? They're congruent. Did I write that wrong? Is that what it says in the book? 2 and 3 are congruent? Just my picture doesn't look very good. So those two are supposed to be congruent. My picture is horrible. Don't go by what my picture looks like. So those two are congruent. We're trying to prove angle 1 is complementary to angle 3. Let's make up a number here. Give me a number for angle 1. Let's make it a sort of easy number. 40. So Michael says angle 1's 40 degrees. If angle 1's 40 degrees, it's complementary to angle 2. What's angle 2 got to be? 50 degrees. If angle 2 and angle 3 are congruent, what do we know about angle 2 or angle 3? I mean, it's 50 degrees. Now let's compare 1 and 3. What do we know about those two? They add up to 90, so they are complementary. All right? Now, John's going, yeah, that worked for 40, but you probably told Michael which angle to pick. Doesn't matter what we pick. Could we pick a different number and work it out the same way? Yeah. So we should be able to go through and prove this. What's our first column called? Statements. Second column? Good. Hopefully you don't have to read my cursive there because you already know what they mean or what they say. What's our first statement going to be? Angle 1, and shorten this up as much as you can. I had somebody yesterday saying, you give way too much homework, and that's probably true, but if you make it a little shorter on yourself, it's going to, even if it's just a couple of words, if you lose a couple of words on every problem, is that going to make it shorter? Yeah. So angle 1's complementary to angle 2. How do we know that? Given. I need to redo my pen here because it's way off. What's that tell us, that angle 1 and angle 2 are complementary? They add up to 90 degrees. All right? I'm going to do this way because we're going to have a couple of theorems and postulates and stuff today that's going to allow us to not have to go through all the headache that they probably wanted you to go through on this problem. So I'm going to do it this way. We know that these two add up to 90. I'm just going to do the next given. We could put angle 1 plus angle 2 equals 90 degrees and go through all that. I'm going to show you the short way here. The way that after you learn a few more rules, postulates, theorems, axioms, all that stuff, that you'll be able to do. And I'm just going to go angle 2 is congruent to angle 3. How do we know that? It's given. Anytime you have congruent or equals, if I see angle 3 way over here, angle 3 is right here, I could replace it with what other angle? 2, because they're the same, right? If they're the same, you can take out one and replace it with the other. So up here in this first statement, I got angle 1 is complementary to angle 2. I can take out that 2 and replace it with what? Angle 3. So tell me that statement that I'm going to write there. Angle 1 is complementary to angle 3. All I did was took out this 2 and replaced it with 3 because I know 2 and 3 are the same. What property did I just use there? Substitution property. Substitution property. Where do we go to next? What were we trying to prove? 1 was complementary 3. What did we just say? 1's complementary 3. So where do we go next? Nowhere. That's it. 3 steps on that one. That's all you needed on that one. 3 steps. Now they actually wanted you to go through, I bet. They wanted you to go through and make it a lot harder. And I think it's ridiculous to make it harder. They probably wanted you to say angle 1 plus angle 2 equals 90. And then once you say that, then replace angle 2 with angle 3 using substitution. And then go back and say, okay, these two must be complementary because they add up to 90. 3 or 4 extra steps, that's sort of ridiculous. This right here is enough of a proof. Number 3, look at number 3. Give me a second to write it up here and draw the picture and everything. On your paper, when you're doing these 2-column proofs, you should at least draw the picture. I used to make my classes write down all the given and prove, write out the whole problem, but you should at least draw the picture. First part, the given says PQ equals RS. So segment PQ is the same length as segment RS. So you should come over here and mark that those two are congruent. If I get rid of the S down here, what can you tell me about PQ and QR together? They make what? We did that in the first chapter. A whole segment, right? What postulate are we using there? This and this together make what segment? Segment addition postulate. We're going to use that. If I put those two together, what segment do they make together? QS, segment addition postulate again, right? We're going to use that somewhere in our 2-column proof here. If I say this segment plus this segment equals that whole thing, and I say this segment plus that segment equals that whole thing, what part did I add to both of them? To the 2 congruent segments that we knew? Just QR. If you add the same thing to 2 things, if I know Devin and Michael are equal to each other, and I add the same thing to Devin, if I add 15 to Devin and 15 to Michael, is my 2 answers still going to be equal to each other? Yeah. So if I add QR to both those that were already equal, then the new segments should be equal, and that's what we're trying to prove. So we're going to use segment addition postulate somewhere through here. What's your first column again? Statements. I don't mind if you do that even. Just put an S. What's your second column? Reason. What's your first statement going to be? How'd you know that?
It's given.
It's given. Should anybody miss that on the test next week? Should Jeremiah miss that on the test next week? Now once we have that, next thing we're going to do is use that segment addition. We're going to say segment PQ. I'm going to tell you this one, then somebody's going to have to tell me the second part of it. PQ plus QR equals segment
RS plus QR.
PQ plus QR equals what segment? PR.
Pardon me, teachers, for the interruption. At this time, those students who are working the college fair, please report to the office. Again, those students
What's our reason?
who are working the college fair, please report
What
to
did
the
we use?
office.
This plus this equals the whole thing. Segment addition postulate. Segment addition postulate. This is where most of you are going to have troubles coming up with your reason. You're not used to have to give a reason for doing something. All right, that's where most of you have trouble. Now, our third statement and reason going to be just like the second one, except on the other side. So somebody tell me how to write it. What two segments are we adding together on that other side? We got rid of this. RS and QR, so RS plus QR. This segment plus this segment should equal what segment? US, good. What do we know about these two? They're congruent. What do we know about these two? They're the same thing, aren't they? So what should be true about these two? Oh, I'm sorry, I forgot my reason out here. What was my reason? Segment addition postulate. So what do we know about this plus this and this plus this? That should be the same because all we're doing is what? Adding in QR. So that's one we'll write down. PQ plus QR equals RS plus QR. All we did here, and I'm putting in this step because it's probably mathematically correct to do it this way. You maybe could have left it out, but it's probably it's better mathematically this way. What we actually did there is we took this first statement, and we maybe should have put this up here first. We took this first statement and we just added QR to both sides. So all we did was the addition property of equality. Now, a lot of you are probably thinking, well, that's a dumb step. You just told us that the other two are equal to each other. That's true, but we probably need to write it out and explain it out a little better, and that step helps out. What do you know about PQ plus QR right here? It's the same as what? PR. So I can take it out and put in PR. What do you know about RS and plus QR right there? It's the same as what? QS right there. So I can take it out and put in QS. What property did I use if I took this out and replaced it with that, this out and replaced it with that? Substitution again. Substitution property. What were we trying to prove? PR equals QS. Did we do that? That's our two-column proof. How many points would this be worth on the test? 10 points. Watch, because I'm going to show you a couple things just to try to help you out, even if Sam doesn't understand any of these two-column proofs. It's just, he thinks it's all a bunch of garbage. He doesn't even want to learn it. But he still wants to pass this class because he doesn't want to see Eversole 2 years in a row. That'd just be horrible if he had to spend 2 years with Eversole. He does this. Should Sam get a point for this first statement? That's 1. Should he get this point? That's 2. He's got 2 out of 10 already. That's 20%. 20%'s 20 times better than what grade? a 0 by not doing it. He looks at this. Anytime you see something that looks like this, good bet that you're going to use what postulate? Segment addition postulate. Not always, but there's a good chance. Segment addition postulate. So he comes over here and he guesses segment addition postulate on 2 or 3 or 4 of these. Could maybe he get these points then? Hopefully. So maybe he gets a couple more. He knows that the proof maybe has 5 or 6 steps. That's about normal. He goes down through here, he leaves all this blank. He doesn't put anything in here. Nothing whatsoever, because he understands nothing about 2-column proofs. Can he write in the last statement? Where's he going to find that last statement at? What you're trying to prove. So should anybody miss that point? So we know that out of the 10, Sam for sure should get at least how many? 3 points, 30%. All right, now 30% is not a good grade, but you should get at least that many points. If you don't get 30%, that means you didn't put any effort in it whatsoever, and I won't feel sorry for you at all. All right. Again, could he guess on some of these? Have we use substitution property quite often? Yeah. Maybe guess that. Segment addition. Guess that. So maybe he's a good guesser and maybe gets 3 more points, and now all of a sudden instead of just 30%, he's up to a 60% on that 2-column proof. Next question. Any of you want to see work? 13? Problem 13, given angle GFH is congruent to angle GHF. And we are trying to prove, and I'm going to write my proof statement a little different there so we can shorten it up, that angle EFG supplementary to, ignore that stray mark going up the board there, angle GHF. Is that right? GHF. What's supplementary mean again? Add up to 180. Let me draw this picture. My picture, not spectacular. E, F, G, my pen's still way off, H, so we're saying angle GFH, that's this angle, is congruent to angle GHF. So those 2 angles are congruent. Anybody tell me what kind of triangle this is right here then? It's got 2 congruent angles? Isosceles. Something we haven't got to yet, but you probably learned it somewhere along the lines. It's an isosceles triangle. That doesn't help us for this problem. So those 2 are congruent. We're trying to prove that this one and this one out here, are supplementary to each other. What can you tell me about these 2 angles? They're supplementary because together they add up to what kind of angle? 180. What kind of angle is that? Straight angle. Together they add up to a straight angle, so they have to be supplementary. Well, if this one's supplementary to that one, these 2 should be the same. What's that tell you about this one and this one? If we did some numbers again, let's do some numbers. Maybe that'll help out. Give me a measure that this one could be. Make it something sort of easy. Look at it. 110 maybe? If that's 110, tell me what this angle inside here is. 70. So that angle is 70 degrees. If that angle is 70 degrees, what's this angle? 70 degrees also. If that one's 70, this one's 110, what can you tell me about those two angles? They're supplementary. That's what we're trying to prove, isn't it? So we should be able to go through and do this. Anybody have any guesses on what kind of properties we're going to use? No guesses? All right. What's our first statement going to be?
Angle GFH is congruent to angle GHF.
That's an angle symbol. Aiden, does that mess you up when my pen does that?
No.
You can understand it? All right. I'll quit worrying about it then. How do we know that? It was given. What'd you tell me about these two angles right here? They're supplementary. That's the next thing we're going to say. Name this angle over here on the left for me. Angle EFG. 3 letters, right? With the angle symbol. Don't forget that. Just finished grading the final test the other day. Poor young lady knows what she's doing. Forgot the angle symbol on about 5 or 6 problems. So what'd I do to him? Marked him wrong. I felt bad, sort of. Then it went away.
How long did you feel that for?
I'm just kidding. It didn't go away. If it would have went away, I wouldn't have remembered that I marked it wrong. Felt bad because I thought, man, she really tries hard. But what other angle?
GFH.
GFH. We know that those two angles are supplementary. How do you know that they're supplementary? Give me a reason. Two angles that what? Add to 180. Now, they didn't really tell us it's 180. They actually told us it's a straight angle, right? So, two angles that add, and I would accept if you wrote down add to 180, probably the better thing is here, two angles that add to be a straight angle are supplementary. Definition of supplementary angles. Remember, your reason's always going to be definitions, postulates, theorems, properties, some kind of rule. Look at what we have here. We got angle GFH is congruent to GHF there. Notice you have that there, you have that there. So if GFH is the same as GHF, well, I can take out GFH and stick what in its place? GHF. So all I'm going to do is rewrite this whole statement right here, but I'm taking out GFH and putting what in its place? GHF. So tell me how to write it.
Angle EFG supplementary to angle GHF.
Spectacular. What did we do there when you take out something and stick something that's equal to in its place?
Substitution.
Substitution property. Don't make these proofs harder than they are. We're not going to do the kind of proofs that Joe one day is going to do when he's working at Cal Poly or MIT or somewhere doing some kind of major thing to describe black holes or something. We're not doing those kind of proofs. Proof that might take 6 days and have hundreds and hundreds of lines. We're going to do ones that got 3, 4, 5. Don't make them harder than they are. Try. On this one, 6 points. If it was on the test, you get 6 points. Should anybody not get this one? That's 1. How about this one? 2. Should you miss this one? That's 3. You could do absolutely nothing, do absolutely no math, write down those 3 and get a 50%. Could you maybe make a guess over here and put it in substitution? Yeah, we use it quite often. That might be a pretty good guess, right? So now all of a sudden, instead of 50, you're up to 67% by getting that extra point. Try. You don't try. If you write this down, number one, if you write this down, I'm taking off extra points. I never ever want to see that on any paper that you hand in to me. All right? You took the time to write this down. You could have took the time and wrote down substitution property and maybe had a chance of guessing and getting it right. You wrote this down. What'd you know about your answer as soon as you wrote that in? It's wrong. And all it's going to do is upset Mr. Ebersol. Make sure your names are on those. You're going to pass them to your right. You'll pass them to your right once they get over here to the right. Everybody that's over here on this row, you're going to pass them forward to the lovely Morgan. And then Morgan's going to hand them to me. Binders due next week. Go ahead and start writing this down. I'm going to talk a little bit about binders, some other stuff. These are your notes for today. Binders due next week. We went over the binder last time, right? How it's set up and everything. Yeah, go ahead and write it. Just draw the picture of it. We're going to do something with it here in a minute. You're never ever going to do them in here, but we're going to talk about them.
So these are notes.
Yeah. These are your notes for today. Title them. More proofs. More proofs.
Can I just write the boxes because I can't see what's inside?
Yeah, you don't have to write what's in the boxes. Just write the boxes and like the arrows. You should have seen like flow charts in history class or English class. Sometimes they use flow charts and flow something. They use all different kinds of flow things. I don't like them, so we're not going to do it. Next week, I'll have you guys on, today's Thursday, Tuesday, correct? Tuesday. So I'll have you on Tuesday. Page 111 will be due. That's going to be your homework for tonight. All right? And we're going to review for the Chapter 2 test. Chapter 2 test will be on Thursday. Okay? When you're done with your Chapter 2 test, you're going to hand in your binder also on Thursday. This paper right here tells you what needs to be in your binder. I'm going to pass those out here in a few minutes. Once we get done with the notes and stuff, this tells you exactly what needs to be in your binder. Got a list right here of the different notes you need in your binder. So that tells you 1 through 13, the notes that need to be in your binder. Then it's got the list of tests and quizzes that need to be in there. It's got the list of postulates and theorems that need to be in there. All right?
What's quiz PP?
What's PowerPoint? That quiz off that PowerPoint. We're going to talk about it again. Because remind me of that, all right?
Can I get an intermission down, Steve?
Yep. So, this is all what needs to be in your binder. These notes today. Kelsey's thinking about her binder and saying, oh crap, my binder's horrible. Now I'm going to do terrible on it. She writes down these notes today. We look at this. There's 13 sets of notes, 3 tests and quizzes, that's 16. Then the postulates and theorems usually are worth like, I usually split them up so that they're worth like 5 points total or something. So that's 21 points. Somebody's got their calculator out, help me out. What's 1 divided by 21? 1 divided by 21. Don't say the 0 out in front of the decimal. Tell me again. round that up. Today's set of notes is worth about how much? 5%. It's worth 5% of your binder grade. So even if Levi's got nothing else, would this be helpful? 5% better than a 0. Yeah. All right. So even if you have nothing else, putting this in there would be extremely helpful.
I did it. Someone probably put that in there.
No, I have had it happen in the past.
Really?
Yeah.
What about do we rate?
I'm sorry, say again.
I said, what about do we rate?
You just write paragraph proof and whatever you want. I don't care. You don't have to write all this. You don't have to write everything in the little boxes. It's just giving you an example of what they look like. So if you write paragraph proof and write out a paragraph and draw a little couple little squiggly lines or something, good enough. Remember, whose notes are these?
Ours.
Yours.
So how do you create some of these? If they're ours, like,
I look at them.
Do we have anything written?
So I grab your binder, first page right here, it's got your name on it, right? Then I look at the first page of notes, and I know what should be in the first page of notes. So I look through it a little bit, and if it looks like you wrote most everything down and probably have a pretty good idea of what's going on there, I give you a point. If I look at it and you wrote down like the first 2 sentences of the notes and I know the notes were pretty long that day, then I probably skip over it and don't give you anything. So if Caitlin, I know like the 4th day of school when we were doing formulas, she fell asleep and she was drooling on her notes and she wrote down formulas and she got the first one and I remember that she fell asleep. She's not getting any points for that because she didn't write them all down. Does that make sense? I'm not a real stickler on it. I'm not looking at it and making sure you wrote down every single little thing. Again, whose notes are they? Your notes. It's supposed to be beneficial to you. One of these days, you go off to college. Guess how many notes your professor wants you to write down? All of it. Guess how many he's going to ask you to write down? None of it. He's going to say, you write down whatever you want, I don't care. Flow proof. Flow proof looks like this. It starts off giving information and it flows to other boxes. This tells us this, then this leads us to this, then this leads us to that, then we use this and this to lead us over to here, so on, so on. That's all a flow proof is. We're not going to do flow proofs. Again, anytime that you see a flow proof in the book, if I forget to tell you, because I will do that every now and then, if you see it says on problem number 17, do a flow proof, change it to a 2-column proof. So anytime it says do a flow proof, change it to a 2-column proof. Guaranteed, next class, probably be Michael. Michael come in, so that one problem said do a flow proof, so I just didn't do it. And Morgan's going to yell at him and say, Michael, he told you that if it said flow proof, you do what? 2-column proof. Paragraph proof. Every now and then we'll do a paragraph proof. Not a whole lot. You just write a paragraph. So we're writing it out in word form, in sentence form, instead of putting it in 2 columns. I think I said this last time, but just to make sure, anything that's on this PowerPoint goes in what section of your binder? Anything that's on the PowerPoint goes in your notes. So even though this says Theorem 2.3, it still goes where? Your notes. And it's still your responsibility to copy Theorem 2.3 in your theorems and postulates section of your binder. Does that make sense to everybody? I always get, because I get somebody, Ricky over here will take this set of notes and he'll say, oh, it says theorem. So he'll stick it in the theorems and postulates section. Anything that I put up here is notes. All right? Somebody yesterday was saying, this stuff's all common sense. That's what all geometry is, common sense. If I have two right angles, what do you know about them? They're congruent. Common sense stuff. A lot of geometry, that's what it is, common sense. Well, why do we got to explain it then? Yeah. So you can learn to explain stuff, learn to think things out logically. A lot of times you ask your folks a question, and you think, this is ridiculous. This is just, it's not a big deal. But your folks think it's a big deal, right? Same thing here. Got to give them an explanation, got to give them reasons. Why do you need that $20 for the football game tomorrow? They're not just going to, Aiden, your folks probably do, they probably just hand you money all the time, right? All right angles are congruent. That's the first theorem that we're going to cover here. All right angles are congruent. Pretty easy one. Next ones, these are a little harder. Again, the stuff that I write up here, shortened forms. When you write them down, when you copy them out of the back of the book, and it's in that blue section, I think I said that last time, right?
There's a lot of them that look like there.
Huh?
There's a lot of them that look like
Yeah.
there.
It's in this blue section back here in the back of the book. When you copy them down, my explanation will probably be a lot shorter than what theirs is. Somebody read this to me so as everybody's writing it down.
Angles supplementary to the same angle are congruent.
That's the shortened form. Angles supplementary to the same angle are congruent. The book probably says something like, if two angles are supplementary to the same angle, then the two original angles are congruent to each other. Something like that. Shorter form is better. Easier. Pass back your guys' test. I never did do that, did I? So on this, if angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 3, notice they're both supplementary to that same angle. 1 and 2 are both supplementary to angle 3. We just got done doing a problem like this. What's that tell us about angle 1 and angle 2? They got to be congruent. Not supplementary, they got to be congruent. They got to be equal to each other. How about on the next one? Look at this. If angle 1 is supplementary to angle 3, angle 2 is supplementary to angle 4. This is a little different. And I probably should have wrote this in here. Or congruent angles. Could put that in parentheses right there where it says same. If 1 is supplementary to 3, 2 is supplementary to 4, 3 and 4 are congruent to each other, so this angle and this angle are congruent. What's that tell you about angle 1 and angle 2? They got to be congruent to each other. So it could be the same angles that they're both supplementary to, or it could be two angles that are equal to each other that they're both supplementary to. And then the other two angles have to be the same, have to be congruent. 1 and 2 here have to be congruent. Does that make any sense? Raven, that make any sense? Are you lying to me just so I'll quit talking to you? So if I told you this, What can you tell me?
1 and 2 are congruent.
1 and 2 are congruent. All right, that would be the next logical step. What if I gave you this information? What can you tell me from all that? Angle 8 and angle 9 have to be congruent. If those two angles are supplementary to these two angles, which are the same as each other, then those two have to be the same. Next one. Look like the slide didn't even change, right? Because what changed in this one? Instead of supplementary, what? Complementary. And again, you might want to put there beside same in parentheses, or two congruent angles. There's like two different theorems here. Instead of writing down both theorems, I was lazy. I only wanted to write down one because they say the same thing, except one takes out the word same and sticks in or two congruent angles. So it could be the same angle, could both be angle 5, or it could be angle 5 and angle 6, which happen to be equal to each other. If I tell you angle 1's complementary to angle 12 and angle 7's complementary to angle 12,
1 and 7 are congruent.
1 and 7 are congruent. So angle 1 has to be congruent to angle 7. Those two have to have the same measure. So if I told you the measure of angle 1 was 72 degrees, what could you tell me about angle 7? 72 degrees. All that making sense?
What was the next goal?
More proofs. Think for a second. I think we rented our house yesterday, paying for Cooperstown. Youngest son's going next year. Fun. Where'd you guys stay at, you know?
We stayed at this place where it's like right off the lake. We all had like, because whenever we went, we took 2 vans, or like 2 like huge vans, and more like short buses, and just the kids went up to their parents. We took like a college trip. We had like room checks at night and bedtime, so
So
every
that-
day we went up to the actual Hall of Fame and stuff.
You don't remember what place was, well, as a player, you guys stayed different places, so that wouldn't help me. Theorem 2.8, two angles form a linear pair. What's it mean when two angles form a linear pair again? Together they make a what? A line, all right? And they have to be what to each other then? Supplementary, or they have to add up to 180. Pretty common sense theorem there.
How old is he?
He'll be playing 12U next year.
That's the fun part.
That's the first thing they told us, is that the players won't, they stay in their own, like, dorms or whatever, you can't.
I didn't go to the 12-year-old. Played at like a old high school field.
Did you?
Seemed like we were too old to play at those fields. Because it's mostly a 12-year-old tournament.
Oh, and this isn't a theorem, this is a postulate, that's why it seems more common sense. Linear pair, again, remember linear pair means two angles that are a linear pair have to add up to 180 or have to be supplementary. Did you guys play, were you guys in a tournament or were you just doing like the camp?
Tournament.
Was it?
Like on the way there, we stopped in Erie, Pennsylvania, and played games.
Next one, might want to put a big asterisk beside this one. Most important theorem you'll learn this year. Nice thing about it, it's the shortest theorem you'll learn this year. Vertical angles are congruent. We already learned that, right? Vertical angles are congruent. Looking at my picture there, somebody name me a pair of vertical angles. 2 and 3. Name me a linear pair in that picture. 2 and 1. 1 and 3, I thought I heard. 4 and 3. Name me another pair of vertical angles. You already said 2 and 3. 4 and 1. An example down here. If I tell you angle 2 is 110 degrees, what other angles can you find in that picture? What's angle 3? 110. Is that the only one you can find? What else can you find? What's angle 1? How are you going to find it?
70.
Subtract that from 180 to get that that's 70. How about angle 4? How would you find it? Same thing. Subtract it from that from 180, you get 70. So if I give you a picture like that, you should be able to find every one of the angles. If I give you something like this where it says measure of angle 2 equals 10x minus 4, measure of angle 3 equals 6 times x plus 3, somebody tell me the equation you can set up on that. What do you know about angle 2 and angle 3? They're congruent, they're vertical angles. So what equation could we set up? Could we solve that equation then and figure out what x is and find all the angles? Yeah. What if I told you this? What if I told you the measure of angle 2 was 2x, measure of angle 4 was x plus 5? Would you set up the same kind of equation? What do you know about 4 and 2? They have to add up to 180. So would we set them equal to each other? You got to be able to pick that out in a picture. Know that these two you set equal to each other. These two you set up equal to 180. So what would my equation be for that? 2x plus equals, got to be able to set up those different equations. We'll do a lot of problems this year setting up those different equations like that. Got to know, hey, these two are a linear pair, these two are vertical, these two are whatever they happen to be. Might be complementary, whatever. We did this last time, put these as part of your notes. Just stick them right in your binder there with your notes. We're going to work through them. So you got examples in there. On the first 6, everybody got one now? On the first 6, first thing we need to do is draw the picture. So if you read the directions, take a second, read the directions on the for the first 6 there. Anybody think they can come up here and draw that picture on the whiteboard for me? Read it, 8. Does that mean you know? Come on, somebody's got to be able to draw that. Somebody draw the first part.
I can draw it. Can you help me?
Go. You can draw the first part at least, right? What's the first 2 things you're going to draw? 2 lines. You're just going to draw 2 lines that look like this?
Any one of these?
Now use the other one. You're going to draw 2 lines that look like this? No. You're going to draw 2 lines that do what? Intersect, because that's what they told you, right? Draw big. Put some arrows on it. Can't be a line without arrows.
Ignore that line there.
Hurry, and you know you've about used up your limit for the year, right? You've about used up your limit for the year. Like you know, our class. First 9 weeks. Joe, where'd you go? You took off on me. So Joe drew that. Perfect so far. Now the part that he probably didn't understand is where the numbers go. What were the numbers? 1, 2, 3, and 4. Doesn't matter where he puts 1. So put 1 in there somewhere. Spectacular. Now we got to start looking at what it says.
1 and 2 are linear.
1 and 2 are a linear pair. So there's 2 different spots that 2 could go. What are they? Bottom or the top, Sam said. So 2 goes there. Everybody in agreement with that? Then it says 1 and 4 are a linear pair. Well, where's 4 got to go? Bottom.
And 3 is
Well, there's only 1 spot left for 3, right? Spectacular. So that's our picture. Thanks, sir.
Gotcha.
Now we're just going to decide if each of these are true and false, or true or false. Angle 1 is congruent to angle 2. True or false? Are these 2 congruent to each other? No, so it's false. If they were perpendicular, they would be, but they told us that the lines couldn't be perpendicular. Number 2 goes across. I'm going up and down, but number 2 goes across. Angle 1 and angle 3 are congruent. True or false? True. They're vertical angles. Number 3, angle 1 and angle 4 are congruent. True or false? False. Number 4, angle 3 and angle 2 are congruent. True or false? Number 5, angle 2 and angle 4 are congruent. True or false? Because what kind of angles are they? Vertical angles again, right? Number 6, angle 3 plus angle 4 equals 180. Angle 3 plus angle 4 equals 180. True or false? I heard both answers. It's true. What kind of angles are 3 and 4 to each other again? Supplementary. What's another name? Linear pair. Oops, didn't mean to do that. Number 7. I'm not going to write all the given and stuff there. I'm just going to draw the picture out here and you can help me with the given. We're going to write a 2-column proof for this picture. What's the first piece of given information tell us? What's that upside down T symbol mean?
Nothing on the same line.
Perpendicular. What's perpendicular mean? Forms a right angle, right? So what do they say is perpendicular? AB and BD. So what do we know about this whole angle right here? It's a right angle. So let's put a little box in our picture there. Draw that little box in your picture. Then they tell us another one's perpendicular, don't they? ED and DB. So what can we put in this whole angle right here? Another box. So draw that box right in your picture there. Getting any of this, John? Looks like you slobbered on my desk. So we got those two boxes. What's that tell us about this whole angle and this whole angle? What do we know about angle ABD and angle EDB? They add up to 180, that's true. They're supplementary. Something else. We just had a theorem that said what's true about those two angles. They're both right angles, so they must be congruent to each other. I don't know if that's going to help us or not, but probably not. What else do they tell us?
So the two angles, ABC and EDC.
Angle ABC. Trace angle ABC on your paper. Angle ABC. It's saying it's congruent, so I'm going to put some kind of arc in here. Maybe you put an arc with a little tick mark on it. Doesn't matter to me how you mark it as long as you know that what it means. What angle is it congruent to? EDC. So let's trace angle EDC. That's that angle right there, right? How am I going to mark it if I mark this one this way? Same way. What can you tell me about these two angles? They add up to 90. How about these two? Add up to 90. These two are complementary, these two are complementary, right? If these two are congruent, this one's complementary to this one's complementary to that one. What's that tell you about these two angles? They're congruent to each other. I believe that's what we're trying to prove, isn't it? What's our first column called? Statements, reasons. Number one, what's your first statement going to be?
AB is, or segment AB is perpendicular
DB?
to BD.
BD? Doesn't matter really, but same thing. How do we know that? Given. As soon as you told me that those two were perpendicular, what'd you tell me about this angle? It's a right angle, so that's what we're going to say next. Number two, name that angle for me that's a right angle. A, B, D. Make sure you're using your symbols. Angle ABD is a right angle. Anybody have a guess how we knew that that was a right angle? Perpendicular lines form what? Right angles, and that's what you write. Perpendicular lines form right angles. Definition of perpendicular lines, just a shortened form of it. Perpendicular lines form right angles. Then where did we go next after we've said that that was a right angle?
ED is perpendicular to
Say it again. ED. ED is perpendicular to BD.
Yeah.
How do we know that? Given. Anybody have a good guess what the next statement's going to be?
Angle EDB is a right angle.
Same pattern as the first two, right? This angle right here then we know is a right angle. So angle EDB is right angle. How do we know that? Perpendicular lines form right angles. Got lines that are perpendicular, got that upside down T, then they have to form right angles. Now is where a lot of you are probably going to get stuck. What can we say about these two angles? They're complementary because they add up to a right angle, right? And that's what we're going to say. Name these two angles for me. Angle ABC, and we're going to just write ABC comp. What's the other angle? Be careful. CBD. I think I heard it. Somebody said DBC. That'd be the same angle. Let's see how they named it. I think they use C first, so we'll use C first. So CBD. How do we know that those two angles are complementary?
ABD is right.
So we gotta sort of write it out here. Two angles add to a right angle are what kind of angles to each other? Complementary. If two angles add up to equal a right angle, then they're complementary to each other. What do you think is going to come next?
EDC is complementary to CDB. Oh no, right? CDB.
CDB. How do we know that?
Because two angles add to a right angle are complementary.
Same as the one right before. Now we haven't used all the given information yet. We're going to use this next. The last piece of given information. What was the other piece of given information that they told us?
Angle ABC is congruent to angle EDC.
ABC is congruent to angle, what angle?
EDC.
EDC. How do we know that? It was given to you. Now Brandon's looking at this and he's thinking, where's all this leading us to? You got to look back here. Look at the things that you've done before. Anybody see ABC right here? It's in both those, isn't it? Anybody see EDC? It's right there. If these two are congruent and they're complementary to these two, we just had a theorem that said if angles comp to congruent angles, then those angles have to be what? Congruent. Oops. What did I do? Mess up my numbers?
Jeez, I was wondering why you did that.
6, 7, 8. Thanks for helping me out.
I was
Make me
gonna
look
say something, but
stupid.
you're talking.
Oh, all right. Thank you, Michael, for not being rude then. What two angles have to be congruent to each other? It's what we were trying to prove. These two are complementary to these two. These two are congruent. What's that tell us about these two? Let's look at it over here. If I told you this angle was 30 degrees, what's this angle over here have to be? 30 degrees. What's this angle have to be? 60. What's this angle have to be? 60. What's that tell us about these two angles right here? They're both the same measure, so they have to be congruent. Name those two angles for me.
Angle CBD and angle CBB.
Look at the proof statement, and that would be where it's at. How many points would that be worth on a test? 16 points. A lot of points. 16 points. Should anybody miss these first two? How about these two in step 3? So that's 4 points. How about the two down here in step 7? That's 6 points. Should anybody miss that one? That's the proof statement, so that's 7. So you got 7 out of 16 points. Doing absolutely no math work. You got 7 out of 16. couple of things because I want to make sure that we have time. The quiz. If you go to, because I didn't explain it very well to this class last time, if you go to Moodle under week 7, this quiz will be collected next class. No ifs, ands, or buts. Go to under week 7. I think it's down towards the bottom. It probably won't be towards the bottom by the end of the day because I'll probably add on today's stuff on there for today. But you want to look for notes 2-5. It's a PowerPoint, just like my PowerPoint here. It'll say notes 2-5. There's a quiz on there that I want you to do. I think it's the second slide on the PowerPoint. I'm letting Shelby do this quiz at home. What should everybody's grade be on this quiz? It should be 100. If it's not, then you didn't put a whole lot of effort into it, right? Get somebody to help you. I think Sam, you're in my intervention, right? Is there somebody in there that maybe knows geometry better than you? So could they help you? Yeah. You think I'd throw a big fit? Probably not. So get somebody to help you. Make sure you know how to do it. Make sure you do that quiz. Let's do next time. Other thing, I'm going to pass these out. While I'm doing this, somebody who's not a jerk, help me out.
I'll help you out right now, dude.
Split them up. Now the reason I need you not to be a jerk is you can't look at somebody's grade and then laugh at them or something ridiculous. You're going to get me in trouble if that happens. Make sure that these tests that they're passing back to you get into your binders where they belong. Appreciate it, young men, you helping me out. While they're doing that, I'm going to explain this. This tells you what needs to be in your binder and how it should be separated. You got 3 sections, 1, 2, 3. Notes section. These are the titles of the notes that should be in your notes section. So you could look through here. What I would do is during intervention maybe, grab your binder, flip through it, check off the stuff that you have in there. If you don't have a set of notes, you could go on Moodle and try to find it, or get somebody else's notes and try to find and get it off of one of your friends. The tests and quizzes. You got quiz page 28. I wrote that wrong. It was called 1-1 to 1-3. It was that quiz, but it was on page 28 in the book. I just didn't type it very well. You have the chapter test, and then you have the quiz off the PowerPoint that you don't have back yet, but you're going to turn in next time, and hopefully I'll give them back to you right before you turn your binder in, and you can stick them right in there. And then the postulates and theorems in the blue section, the back of the book, go in your postulates and theorems, copy down 1.2 for postulates, 1.2 through 2.8. And on the theorems is on the next page, 2.1 through 2.6. I think last year, I remember doing this last year, and it took somebody like 10 to 15 minutes during intervention to get them all copied down. All right?
Did you do our makeup quizzes or redo quizzes?
Yeah.
Tests?
Oh, no, the redo test? No.
Yeah.
I haven't graded them, put them in Moodle yet.
Okay.
Because I got like the last couple yesterday.
Okay.
I haven't done them yet. They'll be in before the end of the 9 weeks. Anybody have any questions over any of that stuff? Sorry? Oh, assignment. up 4 minutes early. That's
Nice.
way too, I'm not used to it. The assignment's on page 111.
Sure.
Yep.
How did that come? Does that just add on to my total grade or?
I just, when I count up, so I do like this. I just count up the numbers that I write at the bottom of the page that you missed.
Oh, okay, I didn't see those pages.
So then
I
minus
thought-
3, then that's-
I didn't see those. Whatever you were writing.
I apologize, Morgan. I left this laying here that whole time, not my job. When you come in during intervention, I'll do it. Yep. And I know this video is going to be a little messed up because I've done some of these problems with some of my classes, but I'm going to go ahead and just start over on the handout that goes for the notes. And if you happen to watch this, you can look back and look at these. I'm going to do all of them added to the video. 1 through 6. On 1 through 6, they say you got two lines that are not perpendicular, so we're going to draw two lines that intersect. But these two lines, we don't want them to be perpendicular to each other, so we don't want them to come together to form right angles. And they said such that angle 1 and angle 2 are linear pairs. So I'm going to put angle 1 in here. Well, to be a linear pair, angle 2 can't go right there because those would be vertical angles. So it's got to go one of these two spots. It makes no difference which one you put it in. I'll put it in that one. Angle 1 and angle 4 are a linear pair. Well, then to be a linear pair again, it can't go there, so it's got to go over here. So 4 goes over there. That means 3 has to be there. And they say, number 1, they just want us to answer true or false. Let's do this. Number 1, number 2, number 3. So it looks the same as on your paper. Number 4, number 5, number 6, and we're just going to put true or false for each one of those. Number 1 says angle 1 is congruent to angle 2. So we look at angle 1, angle 2. The congruent ones are going to be the vertical angles. Ones like that. 1 and 2 are going to be supplementary. And since they said they can't be perpendicular, then they both can't be 90, so 1 and 2 can't be congruent, so that's false. Number 2 says 1 and 3. 1 and 3 are vertical angles, so yes, they are congruent, so that's true. Number 3 says angle 1 and angle 4. They're a linear pair, so they're not congruent, so that's false. Number 4 says angle 3 and angle 2. Again, linear pair, so they're not congruent, so that's false. Angle 2 and angle 4 are vertical angles, so they are congruent, so that's true. Number 6 says angle 3 plus angle 4 equals 180. 3 and 4 are a linear pair, so yes, those two together should add up to be 180, so that one's true. So that's numbers 1 through 6. Number 7, they tell us that segment AB is perpendicular to segment BD. Remember that upside down T, that perpendicular tells us that those two come together and form a right angle. So AB is right here, BD is here, tells us this whole angle right here is a right angle. So I'm going to put the box in there so I remember that it's a right angle. Segment ED is perpendicular to segment BD. So ED is over here, BD is here, tells us this whole thing's a right angle. So as of right now, we know that angle ABD is a right angle, angle EDB is a right angle. That's the information we can conclude from what they've told us so far. Then they tell us angle ABC, ABC, that's that angle, is congruent to, so I'm gonna mark it, angle EDC. That's that angle. Make sure you mark them the same so that we know that those two angles are congruent or have the same measure. And we're trying to prove that this angle is congruent to that angle. This angle right here is congruent to that angle right there. So we look at this, there's several different ways to do it. I may have done it a completely different way on the video the first time that I done it, if I've done this one on this video. But either way, no matter which way I did it the first time, there's many different ways that you could do it. We could use segment addition postulate, we could use complementary angles, so on, so on, so on. I'm going to use the complementary angles. I can't remember if that's the way I did it the first time or not. So we're looking at this, we know that these two angles are complementary to each other because together they add up to be that right angle. We know that these two angles are complementary angles because together they add up to be that right angle. If these two add up to be this right angle, these two add up to be that right angle, and we know this one is congruent to this one, then that tells us that these two that we're trying to prove congruent must be. We had a theorem today that said if two angles are complementary to two congruent angles, then those two angles must be congruent. So that's the way I'm going to go through, and I should be able to go through and write out the two-column proof. Remember, on your two-column proofs, statements, reasons. For every statement you make, you got to have a reason for it. You got to give a rule or a theorem or a postulate or a definition explaining it. So on this one, first thing we're going to say is segment AB is perpendicular to segment BD. And we knew that because it was given to us. They told us that. Once we know that we have perpendicular lines, next thing you need to say, next logical thing to say, is those perpendicular lines come together and they form a right angle. So if AB comes together with BD, they form a right angle. That's angle ABD. So that's what we're going to say next. Angle ABD is a right angle. And I abbreviate a lot of stuff. Make sure you know how to abbreviate, make things shorter on it. How do we know that was a right angle? Because what we were told up here in number 1, perpendicular lines form right angles. It's going to be a definition that we're going to use throughout the year. Same idea for 1 and 2 as we're going to do for 3 and 4. They're sort of going to go together. We're going to say the next given, which is segment ED, is perpendicular to segment BD. And again, that was given to us. Then as soon as we know that this is perpendicular to that angle that I just drew there then must be a right angle. So angle EDB is a right angle. How did we know that? Same as up here in number 2. Perpendicular lines form right angles. Perpendicular lines form right angles. Once we know we have right angles, then what we can say about these two angles is that they must be complementary. So I'm going to name those two angles and say that they're complementary. Angle ABC is complementary to angle CBD. And the way I knew that is because those two angles add up to be that right angle right there. So if two angles add to be a right angle, then are complementary angles. You could shorten it up a little bit. I added a little more in there just to make sure everybody understands it. Two angles add up to be a right angle, then they are called complementary angles. Number 6, we're going to do basically the same thing. We're going to go to the other side and say that these two angles are complementary. So angle EDC is complementary to angle CDB. And our reason for that, exact same thing. Two angles add to be right angle are complementary. And I shortened that up a little bit so we had less writing. It says the same thing as reason number 5. Number 7. Sort of stuck here, so if I get stuck, next thing I do is look back at the given, and I look up here, oh, I haven't used that given yet. So I'm going to stick it in here and say angle ABC is congruent to angle EDC. And we knew that because it was given to us. Now look at what we have. We got ABC right there, well, we also had ABC up here. We had EDC right here, we also had it up here. We know that these two are congruent to each other. We had a theorem today that said if these two angles are complementary to two angles that are congruent to each other, then these two angles have to be congruent. And so now what we can say is that this angle is congruent to that angle. So we know that they have to be the same, have to have the same measure. So angle CBD has to be congruent to angle CDB. Two different angles, don't think that they're the same angle, not the reflexive property, because you change the order. You're looking at this angle right here, and you're looking at this angle, one right there. And the way we knew that is that theorem that we had today, and we had a shortened form of it. It said two angles complementary to congruent angles are congruent. Two angles complementary to two congruent angles must be congruent. So 8 steps, 8 statements, 8 reasons for that proof. Number 8. Number 8, this one's sort of the same as number 7 was, except now we're dealing with supplementary angles instead of complementary angles. I wrote the given a little different than what they had it written down, means the same thing. So they tell us angle 1 and angle 2 are supplementary, so these two are supplementary. And they tell us angle 1 and angle 3 are supplementary, so those two are supplementary. Well, we had a theorem today that said if two angles, so angle 2 and angle 3, are supplementary to the same angle, they're both supplementary to 1, then those two angles, the 2 and the 3 here, must be congruent to each other. And that's what we're trying to prove. So this one should be a fairly easy one. Statements, reasons, again, you can just put S and R if you like. Number 1, first thing we're going to write, angle 1, supplementary to angle 2. And how do we know that? Because it was given to us. Number 2, we could go through and say, okay, then the measure of angle 1 plus the measure of angle 2 equals 180. And we could go through and prove this theorem by using algebra. But since we have that theorem, we don't need to go through and do all that. So we're not going to say that they add up to 180. We're just going to say the next given statement. Angle 1 sorry, my pen quit working for a second. Angle 1 is supplementary to angle 3. That was given to us. Again, the theorem that we covered in class said if these two angles are supplementary to the same angle, then they must be congruent to each other. So now we can say angle 2 is congruent to angle 3. And the theorem was angles supplementary to the same angle are congruent. So if they're supplementary to the same angle, then those angles must be congruent. That's number 8. Number 9. On number 9, they tell us that the hexagon is regular. Hexagon, you've got to remember, has 6 sides. And for it to be regular, that means all the sides are equal to each other. So we know that all these segments are the exact same length, which doesn't help us for this problem. But we also know that all the angles are congruent to each other. So this angle, this angle, this angle, this angle, this angle, this angle, all 6 of them are congruent to each other. Well, right away, if that's a regular hexagon and all 6 of these angles are congruent, then we know angle 3 and angle 4 are congruent. And that might help us somewhere. It might be something that we need to see in our 2-column proof. We're trying to prove that the measure of angle 1 plus the measure of angle 2 equals 180. So this angle plus this angle must add up to 180. Well, we know angle 1 and angle 4 are congruent because they are vertical angles. So I'm going to mark it the same as I marked angle 4. Well, 4 and 3 were the same because it was a regular hexagon. So that tells us 1 and 3 have to be congruent to each other. We'll probably use that somewhere in our proof. We look over here, we know 3 and 2, those two together have to add up to 180. Well, if 1 and 3 are congruent and 3 and 2 add up to 180, we should be able to mathematically show that 1 and 2 also have to add up to 180 by using the substitution property. So that's what we're going to go through here and do. Statement, reason. Our first statement, hexagon is regular. That's what they told us. So that was given to us. Once we know that hexagon is regular, we can say angle 3 has to be congruent to, and we probably, instead of saying congruent, since we have an equal sign here, we probably want to just use an equal sign. So I'm going to erase this, and I'm going to, instead of saying angle 3 is congruent to angle 4, I am going to say the measure of angle 4 equals the measure of angle 3. Means the same thing as angle 4 being congruent to angle 3. It's just the appropriate way to do it algebraically or geometrically. Number 2, the reason we knew that is because it was regular. The hexagon was regular, and in a regular hexagon or any regular polygon, all the angles are the same. So if regular, then all angles are congruent. If it's regular, then all the angles are congruent. Number 3, see what we have next here. We said 1 and 4 are congruent, so I'm going to put measure of angle 4 equals the measure of angle 1. And we knew that because those two are vertical angles. And vertical angles, shortest theorem in the book, probably the most important theorem in the book, vertical angles are congruent. Now if we look at 2 and 3 here, we got 4 in both of them. Well, 4 is congruent to, or equal to angle 3. 4 is also congruent to angle 1. That tells us that the measure of angle 3 must be equal to, that's a 3 there, must be equal to the measure of angle 1. And all we did there was we used substitution property. Substitution property. We took out one thing and we took out the angle 1 right here and stuck angle 3 in its place, or whichever way you wanted to go. Number 5, just took out something, you took out something that was equal to and stuck something equal to it back in its place. Once we have that, if we look over here, we know angle 2 and angle 3 got to add up to 180. So I'm going to say measure of angle 3 plus the measure of angle 2 equals 180 degrees. And we knew that because these two angles, we had that theorem today, those two angles are a linear pair. So a linear pair, we had this theorem, linear pairs add to 180 degrees. Now if we look at what we got in 4, we look at what we got in 5, we know angle 3 and angle 1 are the same. So I can take out angle 3 right here and stick angle 1 in its place by using substitution. So the measure of angle 1 plus everything else in that, it's going to stay the same. Measure of angle 2 equals 180. That's what we're trying to prove. So that's why we did that. We got it to what we were trying to prove. And what we did there was, again, substitution property. We took out something, stuck something of equal value in its place. So that's number 9. All right, on the back side. On the back side it says, complete each exercise, find the answer. In the answer column, write the word under the answer in the box containing the exercise letter. So A, we're going to find the answer to it, and we're going to write it up here in the box. All right angles are, so for A, the blank, all right angles are, we had this theorem today, and it's congruent. We look down through there, I don't see the symbol for congruent, but let's see, do we see the word congruent anywhere? Yep, it's over there on the left-hand side. And on that box on the left-hand side where it says congruent, the word is make. So that tells us in box A up here, we put in the word make. Letter B says blank angles form a straight line. I dislike this question very much because it says straight line at the end. Well, all lines are straight. There shouldn't be anything anywhere that ever says it's a straight line. There's no such thing as a crooked line. So blank angles form a straight line. We're looking down through there, and I see supplementary, but I also see linear pair. And maybe either one of those could fit in there. So let's hold off on that one. It's going to be one of those two, but maybe we're not sure which one yet. Letter C says if two angles form a blank, then they are supplementary. That one I think for sure is linear pair. But again, I'm going to hold off on those two. We'll see. Letter D. When two lines intersect, the blank angles are congruent. So if you got two lines that intersect, if I draw two lines over here and they intersect, these angles that are across from each other are congruent. If I could draw them in there better. Those are vertical angles. So letter D should be vertical. Vertical. Let's see if that's one of the words somewhere over here. Yep, it's down at the very bottom on the left, and that word is of. So in D, This should be of. Letter E. Letter E, they ask us to find the measure of angle 2. I'm not sure why I put equals there. We want to find the measure of angle 2. And letter F asks us to find the measure of angle 3. So we're going to find those two. I'm going to draw the picture over here real quick. They tell us that this is angle 1, this is angle 2, this is angle 3, this is angle 4, and they tell us that angle 1 right here is 67 degrees. Well, if angle 1 is 67 degrees, angle 3's got to be 67 degrees because they're vertical angles. So that angle is 67 degrees. Angle 3 and angle 2 are a linear pair, so we just take 180 minus 67, and you end up with 113 degrees. If angle 2 is 113, then that means angle 4 up here has to be 113. So we go back over here, we were looking for angle 2, which is 113 degrees, and we're looking for angle 3, which we now know is 67 degrees. So for E, we look for the answer 113 degrees. That's on the left, about halfway down. So for E, we put in the word them. Them. And then for F, we know that the answer is 67, so we find 67, which is on the top right of the boxes. That's the word is. So is goes right there in F. Then G and H. I'm going to erase a little bit of this so that I got more room to draw this picture. G wants us to find X, figure out what X equals, and H wants us to find Y, figure out what Y equals, and we got this picture. We know that this angle is 2x, this is x plus y, this is x plus 60, and this one down here is y plus 20. Now there's many, many different equations you can set up from this. One of the equations we could set up is we know this angle and this angle have to add up to be 180. They're a linear pair. But if I set that up, I got 2x plus x plus y equals 180. That equation has an x in it and it has a y in it. That makes the equation harder to solve. Doesn't mean we can't solve it, we just have to use systems of equations. And that's something you should have learned in algebra. But if there's an easier way, we want to take the easier way. So when I look at this, I look at these two angles, and I notice they're a linear pair. So 2x plus x plus 60 should also equal 180. Well, in that equation, I only have x's, no y's. So that's going to be easier to solve. So that's what I'm going to try to solve. 3x plus 60 equals 180. Subtract 60 on both sides. 3x equals 120. Divide by 3. X equals 40. So I know x is 40. So I look at G, look for 40 somewhere. Hopefully that's on there somewhere, and it is. It's over on the left towards the bottom, and it's just the letter A. So A goes in G right there. Then we got to find Y. Again, try to make it as easy as possible on yourself. So I probably don't want to do this equation. I know that these two angles are congruent to each other, but this one has an x and a y in it. I want to somehow get away from having an x and a y. I already know that x is 40, so right here in this one, I could take out that x and stick 40 in its place, and 2 times 40 is 80. So that angle has to be 80 degrees. Well, if that angle's 80 degrees, then this angle down here has to be 80 degrees because they're vertical angles. So the equation I could set up from that is y plus 20 equals 80. And that's a pretty easy equation to solve. So I subtract 20 on both sides, and I end up with y equals 60. So this angle right here, or that variable y is 60. We look on our paper, hopefully 60 is on there somewhere. It's on the right-hand side, about 3 down, and it says match. Now let's go back to B and C and see if we can figure out. I'm going to guess, since I'm pretty sure this one's a linear pair, then linear pair is probably not this one, and this one's probably supplementary. So let's stick those words in there and see if the sentence makes sense. For supplementary, it looks like that word is sure. So we're going to put sure in here for B. And for a linear pair, looks like 1. So we're going to put 1 in here for C. The question was, how can you make sure to start a fire with 2 sticks? And the answer that we came up with was, make sure one of them is a match.